Alrighty, friends, here we are. We are going to be looking today at Module 2, Lesson 5, and today's date is 9/23/22. So make sure that you have your paper labeled as well. You're on a brand new sheet of paper. And as always, as we're going through the video, if you need to pause it to get caught up or you need to do anything with it, feel free to pause it before moving on. All right. Our first problem, first of all, what we're doing today is we're taking what we did yesterday and now putting it into more of a model using the distributed property and then connecting it to partial products, the box method that you guys got introduced to last year, as well as looking at the standard algorithm, but we're not doing any renaming today. So the first problem that I want to look at is 21 times 5. And remember, if I'm writing, you're writing as well. So first things first, I'm going to be looking at place values here. And I notice 21 has 2 place values and 5 has just 1. That's going to be important come later on when I go to make my boxes. So I'm going to look at 21, and like yesterday, I want to go ahead and split this up. I want to split this up into 20 plus 1. This is going to help me with my partial products times 5. So looking at this, I'm going to go ahead and draw me a box to be ready for my partial products. I'm going to put my 5 off to the side. And then since I have 2 place values, I'm going to split it in half for 1 place value, 2 place values. 20 is going to go above 1, and 1 is going above the other. And now, just like we did yesterday where we went 20 times 5, 1 times 5, and we brought it down in parentheses, today we're going to do that just in the boxes. So I'm going to look on my left side, look on my top side, and I'm going to drag my fingers together. So in this box, I'm doing 20 times 5. Well, mental math tells me 2 times 5 is 10. Add back a 0, and that gives me 100. In my other column, I'm doing 1 times 5, which just gives me 5. So now I have 100 and I have 5. Outside of the box, we are going to add these together to get an answer of 105. So those are it as a partial product. If I connect this to a standard algorithm, I would have 21 times 5. I'd be looking at my products that I got here. I would have 100 and I would have 5. Add them together and I'm going to get 105. Remember, I'm not solving through the standard algorithm. I'm just relating to it. Okay, I'm just relating to it at the moment. All right, let's look at the next problem. Let's say we have 23 times 31. Well, I'm going to ask myself here, which of these two numbers is it going to be a little bit easier to count by than the other? And, looking at this, I think it's going to be a little bit easier to count by 23s than by 31s. So we're going to break up 31. So we're going to have here 23 times, we're going to go 30 plus 1 to get back to 31. Now I got that going. I'm going to go ahead and make my box again. This one's a little bit more to it because I have a bigger number. So I have my 30 and my 1 for 31, and I split it down the middle because there's two place values, two numbers. And then on the side, I'm going to have 23. Well, let's go ahead and multiply the easy one first. We have 23 times 1. That gives me 23. Well, now let's mentally multiply 30 by 23. Well, I'm going to ignore the 0 for right now. I'm going to think, 3 times 3 would give me 9. 3 times 2 would give me 6. If I was ignoring that 0 right now. 3 times 3 is 9. 3 times 2 is 6. And then I add back 1 0. So that was 23 times 30. Just like we did up here, now we're going to add these two together. We have 690 plus 23. Might need to line this one up this time. 0 plus 3 is 3. 9 plus 2 is 11. Bundle the 1. 1 plus 6 is 7. So I should get 713 as an answer. If I showed this as the standard algorithm, I would have 23 times 31. My partial products is 690. And 23. Remember, we're not actually multiplying. We're taking our partial products from next door and putting it into the algorithm. Okay, again, at any time, if you need to pause the video, pause it, and we'll go from there. What if we had a little bit of a bigger problem? Let's say we had 343 times 21. Well, I don't know about you guys. I don't really want to count by 343s. I'd rather count by 21s in this case. Or excuse me, vice versa. I'm going to count by 343s and break up my 21. So essentially we're doing 343 times 20 plus 1. In my head, I think I can do 343 times 20 a lot better than breaking this up into 300 plus 40 plus 3. Okay? I would stick to the two-digit numbers in this case. So here, make my box. What did I do to 21? I broke it up into 20 and 1. Cut it down the middle. And I have 343 off to the side. And think about what am I multiplying in each box. In my first box, I'm going to do 343 times 20. Ignore the 0 for right now and multiply through. 2 times 3 is 6. 2 times 4 is 8. 2 times 3 is 6, and then I add back a 0 to get 6,860 as my first partial product. Then in the other box, I'm doing 343 times 1, which just gives me 343. Well, I got my two partial products. Now I need to add them together. Zero plus 3 is 3. 6 plus 4 is 10. 1 plus 8 plus 3 gives me 12. 1 plus 6 is 7. So I get an answer of 7,203. Again, relating to partial products and the algorithm, which is where we're working our way to. In 343 times 1 would give me 343. 343 times 20 gives me the 6,860. and I add together, which gives me 7,203. So again, if you need to go back and rewatch this video as many times as you need to, I have QR codes that you can scan to rewatch everything. So what we're going to do now is we're going to move into our problem set. Your problem set is going to be on page 76. So this is page 76. And your must-dos, and you can choose to do this on your own or with a partner that you're going to work well with, not someone you're going to talk to. You guys know the spiel. Someone you're going to work well with. And your must-dos is I want you to do number 1, A, and B. Number 1, A, and B. So you're going to draw that area model for your partial products, and then you're going to relate it to your standard algorithm. If you finish those two problems, then your can do is going to be number 2, A. On this one, I want you to try it with just the standard algorithm. That's a review from last year. You guys did the standard algorithm last year. So I want you to review that and try that one. When you finish with the problem set, after you spent about 10, 15 minutes working on it, however long you have, then you're going to get to move on to your exit ticket. No homework tonight. Your exit ticket is going to be your work, and Miss Stone is going to have it, what your exit ticket is. Once you have completed your problem set and she or Miss Lewis have looked at it, they will give you the exit ticket problems to do, and then you'll work on those.